Dear friends, I am here with you with one more video lecture. In this video lecture, what we are going to do is that we will derive ideal gas equation from the gas laws. Then we will think of what do we mean by the absolute zero temperature, and at the end we will see what do we mean by 1 mole of a gas. We know that there are 3 states of matter: solids, liquids and gases. In solids, gas molecules are very close to each other. Intermolecular force of attraction is very strong. The gas molecules are not able to move away from each other. Because of that, the solids possesses a definite shape and definite size. In liquids, as compared to the solids, gas molecules are little bit separated from each other. As compared to solids, the intermolecular force of attraction between the liquid molecules is small. Because of that, the shape of the liquid is the shape of the container. Liquids has definite size. It has definite volume. In gas, the molecules of a gas are widely separated from each other. There is negligible intermolecular force of attraction between the gas molecules. Therefore, the gas molecule occupies all the space available for that, and hence gas do not have its own shape and own size, own volume. Size is related to the volume. In heat and thermodynamics, it is very important to study the behavior of gas, and from that we are able to explain the various natural phenomena related with the gas. Gas has an important property which is different from solids and liquids. The gas is compressible. You can compress the gas. In gases, the molecules of a gas are in a random motion, and because of that, the gas molecules can move in a given space, or they can move in the space available for that, and the space available for the motion of a gas molecule is the volume of the container. Therefore, the gas has important property called as the volume of a gas. Now, this is the container which consists of gas molecules. This gas molecule can move in a container. Because of its motion, the space is available for its motion, and it is the volume of a gas. The gas molecules can move in any direction with any velocity, and because of that the gas molecule collide with each other as well as the walls of the container. During the collision, gas molecule used to exert force, and from that the gas molecule used to exert pressure on the walls of the container. Therefore, one more important property of a gas is it has a pressure. Gas molecules are in a state of random motion, therefore they possess kinetic energy. Because of its kinetic energy, the gas molecule used to have internal energy, and in order to measure the internal energy of a gas molecule and the kinetic energy of gas molecule, we assign a term, that is the temperature of the gas. Therefore, a fixed amount of gas taken in consideration for the study of behavior of a gas used to have the three important physical quantities which indicates the characteristics of a gas are the volume, pressure and absolute temperature for the given mass of a gas. These variables, called as the thermodynamic parameters of the gas, can be related with each other with the help of equation that is called as the gas equation. All the three properties are due to the motion of the gas molecules. Therefore, we call this as the kinetic theory of gases. The pressure, volume and absolute temperature are related with the motion of the gas molecules, and we will see how to derive an ideal gas equation. In order to derive ideal gas equation, we will start with the gas laws. The first, we are thinking of Boyle's law. Boyle's law. Let us consider a filled cylinder with certain amount of gas in it. The cylinder is provided with airtight piston. The certain amount of gas in a cylinder, let it consist of n mole of gas. The volume of a gas, let it is equal to V. The pressure on the cylinder, outside pressure on the cylinder is P. Let the outside pressure on the piston is P. Still the piston is not coming down. It is because the gas inside the cylinder exert equal amount of pressure. Therefore, pressure of gas inside the cylinder is P. If keeping the temperature constant and for given mass of gas, if you increase the pressure on the piston, with increase of pressure, the piston displaces downward, there will be decrease in the volume for the given mass, and keeping temperature constant with increase in pressure, there is decrease in volume. It's very obvious. And from that we are able to say that the pressure of a given mass of a gas is inversely proportional to its volume. This is nothing but a Boyle's law. Boyle's law states that as far as the temperature remains constant, for given mass of a gas, the pressure exerted by the gas is inversely proportional to the volume, and therefore I will write here this pressure is equal to some constant of proportionality divided by volume, and therefore I will write the pressure into volume, that is product of pressure and volume, is constant. It means that for pressure V1, if volume is V1, for pressure P2, its volume is V2, then P1 V1 is equal to P2 V2. The same thing can be represented graphically. How it is so? Let us consider it's a y-axis and this is the x-axis. On the x-axis we will take a pressure as a variable, and on y-axis we will take P into V, the product of pressure and velocity. For given pressure P1, product of P into V is some definite value. For given pressure P2, with increase of pressure there is decrease of volume, so that product P into V is constant. Like that, if you see the graph, the nature of a graph is a straight line which is parallel to the pressure axis. The straight line parallel to the pressure axis indicates that the product of P into V is constant. This is about Boyle's law. Charles' law. Again, in order to study Charles' law, we will consider again a given mass of a gas with n moles in it is heated. When gas is heated, the gas molecules inside the given volume absorb the heat energy. Because of that, its velocity increases, and because of that there is increase of kinetic energy. Because of its increase in velocity, number of collision with the piston increases, more number of molecules will collide per second with the piston, and in this case this piston is free to move. Therefore, with more number of molecules colliding with the piston, and because of the internal force acting on the piston, the piston used to displace upward in order to remain pressure constant. Therefore, keeping its pressure constant by making piston to move freely, the volume of gas increases. The increase in the volume of a gas is because of increase in the temperature of the gas. Therefore, the volume of given mass of a gas is directly proportional to absolute temperature. From this, we will write the volume of a given mass of a gas is equal to some constant divided by absolute temperature. Some constant K into absolute temperature. Therefore, I will write V divided by capital T is a constant quantity. Therefore, V1 divided by T1 is equal to V2 divided by T2. Charles' law states that at constant pressure for a given mass of a gas, the volume of a given mass of a gas is directly proportional to its absolute temperature, and hence V divided by T is constant, that is V1 by T1 is equal to V2 by T2. This is Charles' law. Now, if you plot a graph between the volume and absolute temperature, the nature of graph will be like this one. We will take volume on y-axis and the temperature on x-axis. This is the temperature on x-axis and this is the volume on y-axis. For temperature T1, it has some volume, let it is represented by V1. With increase in temperature, there will be increase in volume. Like that, you will see that with the increase in temperature, there is increase of volume, and that happens linearly. There is linear increase of volume with increase in temperature. Therefore, the nature of a graph is a straight line, and if you extend this straight line, it intercepts on x-axis at some temperature. Now, let it is 0 degree Celsius. The temperature corresponding to the zero volume on the temperature axis is minus 273.15 degrees centigrade. If you repeat the same by reducing the pressure inside the gas, let us consider some of the gas is withdrawn from the cylinder so that there will be decrease of pressure. With that decrease of pressure, again the temperature is increased. With increase of temperature, there will be increase of volume linearly. If you extend the same line so as to allow meet on the x-axis, again it intersects x-axis at minus 273.15 degrees Celsius. Physical significance of this interception is that at this temperature, whatever may be the pressure of gas inside the cylinder, the volume of a gas is been reduced to 0. Therefore, we are not able to further reduce the volume of a gas. The volume of gas is effectively 0, because with the decrease of temperature there is a decrease in the speed of motion, and when it decreased to minus 273.15 degrees centigrade, the gas molecule ceases its motion and thereafter it will not move at all and it will not occupy any space. The volume reduces to 0. Therefore, anything less than this temperature is not possible. Therefore, it is called as the absolute 0 temperature. Absolute 0 is the lowest or the minimum temperature possible below which we cannot move, at temperature at which the volume for any mass, any pressure reduces to 0 is the absolute 0 temperature. Absolute 0 is the starting point of the Kelvin scale. The third one is the Gails law. In Gails law, at constant volume, in order to heat the given amount of a gas inside the cylinder at constant volume, let us consider there is a cylinder filled with a gas, a given mass of a gas filled with given mass with n moles. The cylinder is provided with airtight piston. With the increase in temperature, the speed of motion of molecules increases. They used to collide with the piston. The number of collision per second increases with more and more number of molecules colliding per second, but the piston is not allowed to move, it is clamped. Therefore, the piston is not able to move and hence the volume of a given mass of a gas is a constant. With increase in number of collisions per second, there will be increase of pressure with increase of temperature. Therefore, pressure exerted by given mass of a gas is directly proportional to absolute temperature. This is the Gails law. P directly proportional to capital T. Therefore, P is equal to some constant into capital T. Therefore, P divided by capital T is constant, and hence we will write P1 upon T1 is equal to P2 upon T2. P1 upon T1 is equal to P2 upon T2. Again, if you plot a graph between the pressure and the temperature by taking temperature on x-axis and pressure on y-axis, with increase in temperature there will be increase of pressure. The increase in temperature increases the pressure linearly. Therefore, nature of a graph is a straight line. The extended straight line will intersect the temperature axis at minus 273.15 degrees centigrade. If some amount of a gas is withdrawn from the cylinder and the volume has been reduced, and for that given constant volume, again, if you plot a graph, the nature of the graph will be again a same straight line intercepting x-axis manner at minus 273.15 degrees centigrade. This means that this is the temperature at which not the volume of given mass of a gas, but also the pressure of given mass of a gas has been reduced to zero. Whatever may be the initial amount of pressure and volume, at this temperature the pressure and volume reduces to zero. Therefore, the temperature below this temperature is not possible. Hence, this temperature is called as the absolute zero temperature.